So I hope I am being audible to all of you, and we're going to take up a topic which is referred as polyprotic titration. Polyprotic titration, amphiprotic species, and then we'll take questions on the same. Uh, Please let me know if there is a problem at any point of time. Now, right away, when it comes to polyprotic titration, naturally I'm going to talk about a polyprotic acid. Polyprotic means more than one hydrogen to dispense away. And the most common example is phosphoric acid. Now, I think I've already spoken about this in the past. Just in case you have done this in the live class, you just want to be a little patient. There are certain results which I want to talk about before, going into their application. Now, right away, three stages of losing H plus, K1, K2, K3. And naturally, when it comes to K1, K2, K3, the stresses of K1, K2, K3 are going to be, the following. I'm not going to write for K1, K2, K3 right now. I'll just write the corresponding values, and the most common values are, suppose they'll give you K1 to be roughly 10 to the power minus 3, K2 to be almost equal to 10 to the power minus 7, K3 to be 10 to the power minus 11, and this is a general trend. K1 much more than Ka2, much more than Ka3. I think I've spoken about this in the past as well. And it's pretty natural, it's pretty obvious. It's pretty natural, it's pretty obvious. They losing H plus one by one, and any day, something negative losing H plus would be a little more challenging. Something, with two negative charge, losing H plus will be even more challenging. So K1 much more than K2, much more than K3 is the case with polyprotic titration almost every time. I think I'm being understood, and what is going to happen in this scenario when what is generally written as three different steps, by now we realize is basically about expressing these set of species naturally coexisting together. And those who are in class 12 would realize that, we do this in polyprotic titration, we do this in zwitterion amino acids. So basically, they're all going to coexist. When you have phosphoric acid put in water, you have phosphoric acid as well as H2PO4 minus, as well as PO4 minus, as well as PO4 minus. They're all going to coexist. But a very high value of K1 compared to K2 compared to K3 would mean that, H plus would come primarily from H3PO4. H plus will come primarily from H3PO4. Now, a few results which I'll want to tell you right away. Hey, we're used to this. C1 minus H, CH. Now you realize that because H3PO4 and the first step, K1 is much more than K2 or K3, plus K2, K3 losing H plus, would also in one way act as a common effect. And eventually, the source of H plus would be the first one only. इससे जितना H plus निकल रहा है वो दूसरे इक्विलिब्रियम को और पीछे ही कर रहा है. मेरे बोलो तो मेरा बात समझ में आ रहा है बच्चे लोग हाँ ना बोलो.
हाँ सर.
तो अगर मान लो फॉस्फोरिक एसिड दिया हुआ है K1, K2, K3 दिया हुआ है, you got to believe that the source of H plus right away would be phosphoric acid via Ka1. So something which we are very used to, like H plus CH, which is going to be root over of K into C, will be root over of Ka1 into C. Yes or no? बच्चे लोग हाँ ना बोलो. And because, just losing a lot of H plus, would be like a common effect for the next equilibrium, this being the primary source of H plus, let's also understand that, H2PO4 minus will dissociate very little. And the amount of H plus would be almost equal to the amount of H2PO4 minus as well. तो चलो हाँ ना बोलो. We believe the value of K1 is so big than K2 or K3 that almost all of H plus will come from K1 only, and under the effect of common N effect, H2PO4 minus will be almost undissociated. So we believe H plus or H2PO4 minus, in this case from phosphoric acid, or in any case of a polyprotic titration, they ask for a given concentration of phosphoric acid or a diprotic, triprotic acid, they ask for pH value or the concentration of different ions. This is the way I'm going to begin. बच्चे लोग हाँ ना बोलो. Now, this is something believe is a very routine stuff. K1 is CHCH, K1 is CHCH upon C1 minus H, which is almost equal to CH square. H is equal to root over of Ka1 by C, and H plus which is CH, H plus which is CH is certainly going to be root over of Ka1 into C. I think this is understood by all of you. बच्चे लोग हाँ ना बोलो. I want to hear some more of you. Please respond with a yes or no.
Yes, sir.
Yes, sir.
Yes, sir.
Well. Now, if they ask about the concentration of HPO4 minus, can I write K2 as H plus HPO4 minus upon H2PO4 minus? Allow me to do this. Yes or no?
Yes, sir.
Yes, sir.
Now, because I believe these were almost equal, almost every time in a general problem, if you have to write for the concentration of the product of the Ka2, that will be equal to Ka2 only. Let this be a known result. This is going to be very, very important in a kind of problem which I'm going to share with you sooner or later. Yes, we can move on. So you have a given amount of phosphoric acid with K1, K2, K3 given. I've told you how to find the amount of H plus as well as H2PO4 minus. And now even HPO4 minus, yes or no? Please go ahead. Respond with a yes or no.
Yes, sir.
What's left is PO4 minus. And naturally, if I have to find for PO4 minus, I'll want to go by the K3, for PO4 minus. Let me write K3 is equal to H plus PO4 minus upon HPO4 minus. I hope I'm doing it all right. That's K3, which is about the third, step of losing H plus. Yes or no? This K3 is obviously a result of the third step of loss of H plus. This one. Simple. Product by reactant. Yes or no? Yes, we can move on.
Sir.
And the amount of PO4 minus, which will obviously want to get from the value of K3 given, and these two have already obtained, would be like K3. I've told you PO4 minus would be as good as K2. And now this H plus is root over of K1 into C? Yes or no?
Yes, sir.
Now, these results are going to be very handy. In case of, polyprotic titration, where right away they'll give you the value of K1, K2, K3, and with a given concentration, they'll want you to find everything, So in general, I'm going to write a problem. I think you have copied it so far. And if you're understanding me so far, naturally, in all cases of problems involving phosphoric acid, biphosphate, carbonic acid, bicarbonate, question of this kind, where for H3PO4, if the values of Ka1 and Ka2 and Ka3 are as expected, find H plus, then pH, then H2PO4 minus, and then HPO4 2 minus, and then PO4 3 minus in a solution of 0.1 molar phosphoric acid aqueous at 298 Kelvin. Hey, I think I'm being understood. Starting with H plus, which is equal to H2PO4 minus, which is CH and root over of K1 into C. बच्चे लोग हाँ ना बोलो. pH in that case would be equal to minus log of 10 to the power minus 4, which is say root of this will be
Root 10 power minus 2.
pH will be equal to 2. Right now, I'm not going into the discussion of whether I should take alpha close to 1, very small compared to 1 or not. I know somebody would be thinking on these lines. Right now, I'm not going into that discussion because naturally, that could be one thought. Avoiding that thought in mind. The rest is exactly what I told you. HPO4 2 minus. You realize I told you will be equal to K2? Yes or no? PO4 3 minus would be like K3 into K2 upon root K1 into into the concentration. I think I'm being understood. बच्चे लोग हाँ ना बोलो.
sir.
Now, this is one kind of problem which I've seen coming very often in the real exam. Please correct me if I make a mistake somewhere.
सही है सर.
कौन है भाई was giving me such a nice compliment?
मेहुल.
मेहुल भाई. आगे बढ़ते हैं दोस्त. So far so good, I believe.
Yes, sir.
Can we move on? I would want people to respond so that I can move at a faster pace.
Yes, sir.
Now, I love to do this problem, which is titration of phosphoric acid using NaOH, and this is a particular setup which I certainly enjoy. 50 ml of 0.1 molar phosphoric acid on adding following volumes of 0.1 molar NaOH, pH at different intervals. I hope what I'm writing is readable. And the intervals which I generally give you is like 0 ml, 25 ml, 50 ml. I might have done this problem in the past. Hardik and Jeenam, you would want to, Ritesa, you would want to confirm.
Yes, sir.
I've done this in the past.
Yes, sir.
So
Am I writing the values all right? 200 ml ऐसे ही कुछ आ गया.
हाँ सर, आई में 90 था सर, 90 मिलीलीटर.
ठीक है, ये तो 100 दे दिया पक्का. जो भी है, I'm really happy to hear from 2 generations from the same school. This is equally interval. This is equally important for every science student doing problem on ionic equilibrium. I love doing this because this is something which is going to make a lot of topics, including titration curve and buffer capacity, and a few things which I'm going to do in future as well. So phosphoric acid 5 millimole to begin with. You add nothing of NaOH, and I think you're understanding me. To begin with, I'll want to get H plus as root over of Ka1 into C. believing the values of K1, K2, K3 are exactly, what I had. I'll get pH is equal to 2.
2.
When you add 25 ml of NaOH, Utsali, can you hear me loud and clear? It's your first class, I believe.
Yes, sir. It will form a buffer.
It will form a buffer. Please be a part of the discussion, that's going to keep this class up and running. So
Yes, so
5
there are going to
millimoles
be
to
5
begin with.
millimoles of H3PO4 which will form, and then 2.5 millimoles of NaOH. So we
this
will have
be left.
2.5
This
of H3PO4
will
and
get over,
2.5.
yes.
Yeah.
Sounds
2.5
good,
will
sounds good.
Yes.
This is left.
And
naturally,
then pH is equal to pKa1 plus log of conjugate base by acid.
and I've said this.
Yeah,
in the
that is
past,
going to
I've
be
said
1.
this in
So
the
it's
past.
going to be 0. Yeah. So it's only going
Yes,
to
it's
be
going to be
3.
0 and pKa1 is 3 certainly,
Yes.
because K1 value is 10 to the power minus 3. And I've said this in the past, it's not incidental. That several times you'll get the two equal, the two equal would be a case when the buffer is the best. This is when the buffer is the best. I'm going to use this by drawing the titration curve. Moving on. When you have 50 ml of NaOH added, now 50 ml of NaOH added is as good as,
Only NaH2PO4 will be left. So we can use pH is equals to pKa1 plus pKa2 by 2.
I would really be really happy to hear, how do you arrive at this? Because this is being your first class. I don't think I have given you a way to arrive at pK1 plus pK2 by 2. Please tell me, how do you conclude?
By salt hydrolysis, we like over here there are two H, right? There are two H.
No,
So we
it's
will
not
use.
by salt hydrolysis.
Yeah,
It's not by salt hydrolysis.
Oh,
It's not by salt hydrolysis. It's not by salt hydrolysis. And this is something, I enjoy doing this. So many times I would have done this redundantly, but, this is something which I'm going to again impose upon you. This is salt hydrolysis. All of you by now realize that this is salt hydrolysis. Again and again, be it acetate to begin with, or a general form which I write. For a weak acid, it's going to be OH minus pH is equal to pKa plus 7 plus half pKa plus half log C. Now, the problem with salt hydrolysis is, it's applicable for the salt or the anion of a monoprotic acid. With H2PO4 minus, the salt hydrolysis would look like this. But naturally, there's going to be another step which is called K2. And I've done this so many times with all of you. Salt
So over here
hydrolysis.
we'll use the formula of concentration of H plus is equal to root C1 alpha 1 plus C2 alpha 2. इससे भी आ सकता है ये शायद से.
इससे भी नहीं आएगा, उससे भी नहीं आएगा, ये एक ही तरीका से आएगा. मैं जब पढ़ाता हूँ ना तो मैं एक चीज बताता हूँ, मैं एक बात बताता हूँ, उसको बहुत ध्यान से सुन लो. Utsavi, and I've said this multiple times to everybody who's attending the class right now. I speak a language which is going to sound like, the moment I add NaOH plus CPO4, the moment I add 1 drop of NaOH plus CPO4, I have a buffer. When you're adding NaOH constantly to a CPO4, NaOH is the limiting reagent, you have a weak acid left and the corresponding salt form. From any point, so first drop till 50 ml, from first drop till 50 ml, NaOH being the limiting reagent, will have a mixture of this and this. And every time you have a mixture of this and this, it's going to be a Henderson equation of this kind, which is pK1 plus log of this upon this. I also end up telling you that the moment you cross 50 ml, 50.0001 ml, the moment you cross 50 ml, and I'm going to use that when I add 75 ml, the moment you add OH minus to H2PO4, there's going to be another buffer. There's going to be another buffer, just to give you a particular, heads on, when I have NH2PO4 plus OH minus, it's going to be another buffer. And this buffer would be like Na2HPO4 plus OH minus. So here I'll be certainly using a formula which is like pH is equal to pK2 plus log of H2PO4 minus upon H2PO4 minus. So, the message which I always want to send across people is, from the point of adding NaOH 1 ml or 1 drop till 50 ml, you have this equation at play. And, after 50 ml, when you have another buffer of H2PO4 minus and HPO4 minus, you have another equation at hand. The point is, when you're doing it exactly for 5 ml or 50 ml of NaOH added. When the problem reads only NaH2PO4, and I have to tell you one more time, something which loses OH minus as well as H plus. First of all, I call it amphiprotic. And for amphiprotic species, you can't tell me to apply either short hydrolysis or K2 because both are relevant. Now, when we have more time at hand, this is something which I enjoy doing in the live class. I do tell you that if you have a bit of this and a bit of this, which is exactly one drop before 50 ml, I'll want to write one Henderson equation. Or, one drop after 50 ml, where you have a mixture of this and this, I'll have another buffer equation or Henderson equation. When you have only NaH2PO4, when you have only NH2PO4, and I've used this language in the past as well, it's not like salt hydrolysis. It's different from salt hydrolysis. It's a case of amphiprotic species. When it's only NH2PO4, you believe you have maximum H2PO4 minus. You have only this to speak about. You give me a bit of this and I'll apply one equation. You give me a bit of this, I'll apply another equation. So when you're not talking about this or this, when you're only thinking about this, this is the most logical approach. When you have only H2PO4 minus to consider, this is max only when, the one preceding it and the one succeeding it is equally negligible. Both are completely ignored. Because if you don't ignore this, you have another buffer equation. If you don't ignore this, you have another buffer equation. So, at this point of time, it has to be a constant pH, which is irrespective of the concentration. The concentration would not matter. This will be certainly a constant at a given temperature. It will be like one particular pH point in the entire titration journey where this will be maximum, this will be maximum when, you're not considering this, both are minimum and ignored. Now, when I write the equal and ignored, I quickly write for K1 and K2. Allow me to write for K1, which is certainly this expression, and allow me to write for K2. If somebody has any question to ask around this point or this concept, I absolutely welcome you, because I have never in the past wanted to use any kind of mathematics or any kind of assumption to arrive at this result. Trust me, if it comes in the real exam, this is going to be the easiest question, because what we need to do is find the average of 3 plus 7, yes or no? What we need to do is find the average of 3 plus 7. So when it comes in the real exam, you might have a question like find pH of 0.1 molar, 0.2 molar, 0.5 molar. I think you understand by now this is not relevant, NaH2PO4, and this is going to be the easiest question if the K1, K2 values are given. So Siri, please respond if you understand me. The problem is,
Yes, sir.
when I consider only NH2PO4 and I don't consider any bit of H3PO4 or any bit of Na2HPO4, which means I'm not using any Henderson equation, which is a mixture of, the corresponding conjugate acid or conjugate base. It means I'm talking only about this. And when I'm talking only about this, I'm considering these two are almost equal. Now, when I consider this and this to be almost equal, see, these two even out. When I consider these two are almost equal, K1 into K2 would give me H plus H square. And trust me, it's been so many years of teaching, I don't understand why this bit of logic does not find place in the textbook. I have seen multiple books. All the textbooks would give you such a messed up, solution to this particular result. It's not like I take a lot of pride in solving it myself. I didn't know it when I was your age. But what now? And in class 12, when I do amino acids, this is exactly what we do for zwitterion. Don't you think for zwitterion, I want a particular pH when they do not move to the cathode or not? A particular amino acid will exist in all the 3 forms. It's the ionic form in which they're prevalent. But I say isoelectronic point to be the pH when they do not go to the cathode or not. Now, when they do not go to the cathode or not, it means almost none of the molecules are in a predominantly positive or a predominantly negative form. Zwitterion is the form when the total charge is 0. Zwitterion is the form when they're electrically neutral. So you compare to this discussion to amino acids, which only class 12 people will be able to relate to, and class 11 people you would want to be only. Yes, please.
सर कैन यू प्लीज एक्सप्लेन ये वाला पोर्शन अगेन H3PO4 और HPO4 2 माइनस का जो कंसंट्रेशन आप बोले इक्वल होगा
तो मान ले अगर ये बिल्कुल जरा सा भी होता,
हाँ
had it been any bit of H3PO4, I would want to apply a Henderson equation.
यस
Which will be pK1 plus log of this by this. Had there been a drop of this, I would apply another Henderson equation,
यस
which will be pK2 plus log of this by that. Yes or no?
यस
But I'm not doing that. It means, and I use this particular statement, I use this particular word. This means it's a rigged problem where they talk only about a constant point of the titration journey where the concentration of H2PO4 minus or any amphiprotic species would be maximum only if its hydrolysis product and its ionization product, which is its conjugate acid and conjugate base, are minimum. It's like the maximum minimum concept which we learn in calculus. Apply this for deuterion in amino acids, isoelectronic point, you get a similar equation, isoelectronic point, and that's supposed to be the pH at which none of the molecules go to the cathode or anode. So when you have a statement like none of the molecules go to cathode or anode, it means, these two in context of the corresponding amino acid structures don't exist at all. Yes or no?
Yes, sir.
Moving on. In terms of solving the problem, getting the desired pH value, pK1 plus pK2 by. So we move on to 75 ml. When we move to 75 ml, which is 7.5 ml of OH minus, adding 7.5 ml of OH minus to H3PO4, I believe is understood as good as adding 2.5 millimole to 5 millimole of NH2PO4.
Yes, and again buffer.
And again buffer.
I mean, you'll have a buffer. You'll have a buffer from 50.0001 ml. You'll have a buffer at 49.9999 ml. I mean, this is something we need to be very practical at. Only at 50 ml, we get stuck up and we have to talk about the pH of an amphiprotic species in its maximum concentration. Yes or no? Which obviously is going to be a constant value, irrespective of the concentration, will depend only on the K1, K2 value. In this case, pK1 plus pK2 by 2. Now, this again is going to be pretty interesting in the sense, eventually you'll find this is the requirements for a buffer to be the excellent buffer, the best buffer. This is 7, I believe you understand me. We'll move to state state E. We'll move to state E.
sir.
Now, state E is again going to land me in the same pit where by now I have added 100 ml of OH minus. Now 100 ml of OH minus to phosphoric acid or 10 millimole of OH minus to phosphoric acid is as good as adding 5 millimole to 5 millimole of NH2PO4.
Yes.
I don't mind writing this equation one more time. H3PO4 plus OH minus becomes H2PO4 minus plus water to 5 millimole would have converted 5 millimoles of this to 5 millimoles. And adding 10 millimoles from time t is equal to 0 is like 5 millimole converting this to this. And this is going to be the scenario, yes or no?
Yes.
And right away, I realize this time around, again, I have the same situation where I have to only speak about Na2HPO4. And yet again, you need to be good at it. You need to be good at it. You need to be good at it. My student need to be good at it. H2PO4 minus plus OH minus is how you're going to write for salt hydrolysis. And then HPO4 2 minus, losing H plus and PO4 3 minus is how you're going to lose. This is certainly KH and K3. Yes or no? Allow me to call it amphiprotic because it's losing both OH minus and H plus. And again, this is exactly the point where I'll consider these two to be negligibly equal. And when I consider these two to be negligibly equal, I write for K2 as I'll write for K3 as I think I'm being understood. ये तो cancel होता ही है. And I believe these two are
Okay.
equal. I believe these two are equal. Yes or no? Which
Yes.
will give me the system of writing K2 into K3 as S plus
Yes.
S square, which will mean S plus S, root over of K2 into K3. And this is how I arrive at PH is equal to PK2 plus PK3 by 2.
By 2.
I would have done this, I kind of took it for granted in the past, I just kind of jumped the gun here. K1 into K2 is S plus square would actually mean S plus is equal to root over of K1 into K2. I could have done this, out here as well. And minus log of H plus would have been like minus half log K1 minus half log K2 is how you arrive at pH is equal to PK1 plus PK. Yes or no? You'll have naturally two asymptotic species here. You'll have naturally two asymptotic species here. So far, so good, I believe. So again, from the standpoint of getting the answer only, it's simple like 7 plus 11 by 2, and this will give you 9. And only when, they go this far, that, you have to explain arriving at this expression. Trust me, you'll want to relate it with the, isoelectronic point in amino acids, particularly people in class 12, for realizing that, the one which is the ionization product or hydrolysis product has to be the one, which has to be in oblivion. We'll want to move on. Just you can move on. Next is state S, where I've added 125 ml, I reckon. This I've added 125 ml. Please respond. बच्चे लोग हाँ ना बोलो.
हाँ सर.
हाँ सर.
This will form a buffer again.
This form of buffer again. Naturally,
pH will be 11.
that's 5 millimole of this to begin with. And 5 millimole of this would give you 15 ml of H plus. So 5 millimole यहाँ खत्म हो गया, बाकी 5 millimole यहाँ खत्म हो गया. So adding 125 ml or 12.5 millimole is like adding 5 millimole, 2.5 millimole. Please respond with a yes or no.
Yes sir.
When you have added 125 ml of 2.5 ml by this time, 5 millimole यहाँ पे खत्म हो गया, 5 millimole यहाँ पे खत्म हो गया, 10 millimole OH minus से 5 millimole SPO4 minus minus बना. ये 5 है, इसमें तुम 2.5 ऐड किए हो. So this will be 2.5 millimole left, and this will be 2.5 millimole formed. Yes or no?
Yes sir.
sir.
And
PK3.
natural right swap pH is equal to PK3 plus log of 2.5 upon 2.5. If we are good as PK3, the value being known, it's as
11.
simple as writing the value which is 11.
11. Yes sir.
Now, finally, when you have 200 ml added, which is like, you have got rid of all phosphoric acid. When I eventually write HPO4 2 minus 5 millimole, and around this time I've added 10 millimole of OH minus, now I know that all of the acid is gone. Now this is gone. You have 5 millimole of this left. Yes or no?
Yes.
सर बीच में 150 ml स्किप हो गया सर. 150 ml जब ऐड हो
150 ml skip हो गया. बीच में 150 ml skip हो गया. You are right. बीच में 150 ml skip हो गया, जहां पर naturally ये
5 हो जाएगा.
5 रहेगा,
5 would.
है ना? और यहाँ पर क्या करेंगे बोलो बच्चों? यहाँ पर क्या करेंगे बोलो?
सॉल्ट
5
हाइड्रोलिसिस
moles form हो जाएगा. Salt hydrolysis करेंगे.
यहाँ पर salt hydrolysis करेंगे, because this isn't amphiprotic. I didn't use this term in the past. I only said it orally. Now I'm willing to write it. It's not amphiprotic because this can only behave like acetate. This can only behave like acetate. What I want people to be good at is being able to express this at will, which is anionic hydrolysis. I want you to be really good at this. You need to be producing this at weld. बच्चे लोग हाँ ना बोलो. Naturally, it has taken me a lot of time and effort and and practice to arrive at it. But this is exactly what I write for salt hydrolysis. This far and no further. No longer an amphiprotic species. Applied pH is equal to 7 plus half pKa plus half log 3. And please let me take this as pKa 3. Yes or no? pKa 3 is naturally 11. I'm going to be a little conscious here. 5 millimole in 150 ml लियो 50 ml शुरू में वो था. So it is going to be 5 upon
200.
So far, so good, I believe. So far, so good, I believe.
Yes, sir.
Whatever is the answer, somebody will want to tell me the answer at his or her convenience. What I want to
11.7 है सर.
with, ठीक है, जो भी है.
1.7.
वो 90 ml वाला भी देख लेंगे, 200 ml वाला भी देख लेंगे. एक बार जल्दी से देख लेते हैं. 200 ml वाला में क्या होगा? 200 ml वाला में क्या होगा? 200 ml of NaOH would mean eventually you have taken NaOH, which is like 20 millimole.
So 5
and,
millimoles of NaOH will be left.
5
NaOH
millimole
बच
of
जाएगा तो
Sp.
POH निकाल सकते हो.
बहुत अच्छे. तो ये 5 मिलीमोल SCPO4 जो था, जिससे तुम्हारा 15 मिलीमोल H प्लस आया था, उसमें अगर तुम 20 मिलीमोल OH माइनस लगा दिए हो, तो आप में OH minus left will be 5 millimole. I'll write square bracket and I'll write away like 5 by 250 if I'm not wrong. And POH will be minus log of 5 by 250. Please respond with a yes or no, which is
Yes, sir.
Yes, sir.
log of 50.
5 plus 1. We can break this down. मतलब 1/50 होगा ना, minus log of 1/50, तो log of 50 हो गया वो. फिर log of 5 plus 1.
अरे रुकना, मेरे को उतना मैथ्स नहीं आता. पीएच क्या होगा? 14 माइनस इतने, यही करेंगे ना, यही होगा आंसर.
हाँ सर.
हाँ सर.
चल ठीक है, क्या आएगा बोल.
12.3.
12.3 आएगा.
12.3 100 divided by 2, so 2 minus 0.3.
ठीक है मेरे भाई, थैंक यू सो मच. अब देख, काम करते हैं, अपने टाइट्रेशन कर्व ड्रॉ कर लेते हैं. इतना सारा मेहनत में कर रहा था बिकॉज मेरे को टाइट्रेशन कर्व प्लॉट करना था. अब एक काम करते हैं, टाइट्रेशन कर्व प्लॉट कर लेते हैं जल्दी से ना. ये सारा वैल्यूज देख लेते हैं.
सर एक वो 90 ml वाला.
90 ml रह गया सर.
छोड़ ना उसको, बाद में 90 वो भी कर दूं क्या? अभी बोल, मैं जो लिख रहा हूँ
वैसे भी पहले
जब मैं
सर सीडी
लो,
जैसा
लो।
ग्राफ बनेगा.
सीडी जैसा ग्राफ बनेगा. ठीक है, सीडी जैसा ग्राफ कैसे बनेगा ये उससे भी बोल रही ना, मेरे को एक्सप्लेन करना. ठीक है,
यस सर.
सीडी जैसा ग्राफ कैसे बनेगा मेरे को एक्सप्लेन करना. और ये दिए चाहिए 90 ml वाला भी मैं कर देता हूँ यार. 90 ml NaOH में क्या हो गया? OH माइनस में डाला हूँ 9 मिलीमोल ना.
वापस बफर बने.
तो ये भी बफर रहेगा.
pKa plus log 4 by 1.
It is,
7
I
plus
think,
log.
it is as good as adding 4 millimole of this to 5 millimole of
5
this. हाँ?
millimole of this. Yes, sir.
ठीक कर रहे तो.
सर वो 4 मिलीमोल बनेगा ना.
4 form.
ठीक है, ठीक.
Log 4 by
वाटर
1.
कुछ लेते नहीं, समझ में आता ना. सब तो पानी पानी है. सब तो पानी ही पानी है. pH will be equal to क्या लिखो? pK1 लिखो कि pK2 लिखो? जल्दी बोलो.
pK2 plus log of
pKa 2 plus log of 4 by 1.
pK2 कितना था? 7 था.
हाँ सर.
देख, मैं भी जल्दी कैलकुलेशन कर सकता हूँ. ठीक कर रहा हूँ तो.
हाँ.
तो थैंक यू बोलो यार, गा दिया इतना. कोई थैंक यू नहीं बोलता. आगे बढ़े.
यस सर.
कोई थैंक यू नहीं बोलता.
थैंक यू सर.
Thank you, sir.
कुछ गलती किया हो क्या?
नहीं सर.
गलती तो तुरंत निकालते हो. 1 नहीं होगा, 4 होगा. बोल के थैंक यू बोलवाना पड़ता है यार. क्या है? 2 3 5 7 9 11 ठीक लिखो ना. यहाँ पे क्या था बोल?
11.7.
11.7.
तो क्या था?
12.3.
आई तक गए थे ना अपने तो. आई में क्या था?
सर आई 90 मिलीलीटर था सर. आई बीच में आ जाएगा ना.
अरे बोलना एक बार.
7.6 था।
7.6.
मैं ऐसे 90 में लास्ट में लिखता हूँ जनरली। ये मेरे को लगता है वॉल्यूम ऑफ एनिवर्स का जो वॉल्यूम था ये 0, 25, 50, 75, 100, 125, 150, 200 और 90 यही था ना।
यस सर।
चलो मेरा मदद करो थोड़ा यार ये पीएच कर्व को प्लॉट करने में।
सर सीडी
मैं
जैसा
चाहता
होगा।
मैं चाहता तो ये स्मार्ट बोर्ड को कितना अच्छे से यूज करता। मैं चाहता तो यहाँ पे ग्राफ राफ सब लेकर के आ जाता, पर मैं उतना मेहनत करता ही नहीं हूँ। पता नहीं मेरे को भगवान कब इतना बुद्धि देगा कि वो सब मैं करूंगा। अभी मैं कैसे कितना गंदा तरीका से स्मार्ट बोर्ड यूज करने वाला हूँ देखो, इसको टच भी नहीं कर सकते, ऐसे ये एक बिकता है ये। ठीक है।
हाँ सर।
मोटामोटी बीच में है ना। तो 1.5
हाँ सर, अब ठीक ही है, क्या फर्क।
ठीक ही है, छोड़ो ना। ये बचपन से अपने पास टैलेंट होता है अपने, मोटा मोटी इसको दिमाग से 1, 2, 3, 4, 5 देख 7, 8, 9, 10, 11, 12, 13। अभी तो इस पास बोर्ड में ऑप्शन है ना प्रॉपर बढ़ा सकते 8, 9, 10, 11, 12, 13 ऐसे भी अपने को कहाँ तक 14 तक जाना ही थोड़ी। चलिए ठीक है, साउंड गुड, लुक्स गुड। ठीक है बच्चों आना बोलो।
हाँ
हाँ
सर।
सर.
25, 50, 75, 100, 125। और मैं थोड़ा सा ना स्पेसिंग कम करता जा रहा हूँ बिकॉज 25 को मैं बहुत दूर ले था। 25, 50, 75, 100, 125, 150, 200। ठीक है ना। अरे हाँ ना बोलो यार।
यस सर।
हाँ सर.
तो क्या था यहाँ पे 2 पे लेना है मेरे को, फिर 3 पे लेना है, फिर मेरे को 5 पे लेना है, फिर 7 पे लेना है, फिर 9 पे लेना है, फिर 11 पे लेना है। ये मेन पॉइंट है। तो पहला है 0 ml पे 2 ये लिया। रुक कलर बदलता हूँ। ये लिया पहला पॉइंट। 25 पे ये लिया 3, ठीक कर रहा हूँ तो 50 पे ये लिया 5, ठीक कर रहा हूँ तो। अरे हाँ ना बोलते रहो यार।
हाँ सर.
75 पे क्या लेना है 7। अरे हाँ ना बोलो यार।
हाँ सर.
100 पे 9 ले रहा हूँ, ठीक ले रहा हूँ तो। 125 पे
11.
11 और 150 पे।
11.7.
अच्छा ठीक है, यहाँ पे थोड़ा सा ये डिफरेंट होगा। अब ना ये स्ट्रेट लाइन नहीं होगा, नेचुरली ये स्ट्रेट लाइन नहीं होगा। उसको प्रूव करने के लिए I can have more points on the plot. To prove it's not going to be a straight line, I can either have more lines in the plot, more dots on the plot, different readings, or I'll understand कि बाबा जैसे ही फॉस्फोरिक एसिड में या कोई भी वीक एसिड में OH माइनस डाला, वैसे ही तो ये सीधा एक बफर बन गया ना। तो बफर में तो कभी भी इन दोनों का मिक्सचर में तो कभी भी साफ इंक्रीज नहीं होगा। फिर हाँ नहीं बोलते हो।
हाँ बफर रेस्ट्रिक्ट्स द इंक्रीज ऑफ पीएच, सो इसीलिए वो एक रफली एक स्ट्रेट लाइन टाइप का रहेगा।
रफली वो स्ट्रेट लाइन टाइप का नहीं रहेगा।
नहीं
नहीं
रहेगा.
मतलब वो मतलब अब अभी आपको एग्जैक्टली वर्डिंग से मैं एक्सप्लेन नहीं कर पा रही, ड्राइंग में तो वैसा ही ड्रॉ किया हुआ है।
हाँ तो ठीक है, तू मेरे को बता रहा, मैं तो किसी ही पूछ रहा था कि ये स्टेयर के तरह फिनोमेना क्यों होता है। This is what I wanted to hear from you. A,
सर सॉरी,
B,
कैन यू प्लीज रिपीट वंस, क्या बोले आप?
why does it look like a CD? CD बोले थे ना तो CD। तो
हाँ
CD
हाँ
क्यों? CD क्यों है?
सर क्योंकि पहले तो जब हम लोग पहले तो मतलब ये 2 पे चालू हुआ क्योंकि वॉल्यूम में कुछ था नहीं, तो उसका पीएच ही 2 था। फिर उसके बाद वो बफर था तो इट रेस्ट्रिक्टेड द इंक्रीज ऑफ पीएच। फिर जब वो पीएच खत्म हुआ तो अचानक से देयर वाज अ शार्प इंक्रीज एंड फिर
देख
वापस।
यहाँ से मेरा बात सुन, यहाँ से यहाँ तक ये एक बफर है, यहाँ
हाँ
से यहाँ तक एक बफर है। ठीक है, पॉइंट ए से लेकर के पॉइंट सी तक ये बफर है। मेरा बात समझ में आ रहा है? हाँ ना बोलते रहो। बोलो यार।
हाँ सर, सर सी पे पहला इक्विवेलेंस रीच करेगा इसीलिए इतना शार्प है क्या?
देख, पॉइंट ए से सी तक इट्स बफर 1, इट्स बफर 1 ऑफ H3PO4 एंड बहुत गंदा लग रहा है केक है।
नहीं सर।
अब देखो, throughout this buffer, this is the point when H3PO4 is equal to H2PO4 minus, and this is when the buffer capacity is best. This is when the buffer capacity is best. Yes or no?
Yes, sir.
Now, when the buffer capacity is best, the change in pH with alkali added would be the minimum. So throughout this journey, this will be the point where the slope will be minimum. This would be exactly like a plateau where you move from this to this. Naturally, H3PO4 यहाँ से B से A में आओगे तो phosphoric acid ज्यादा होगा, B से C में जाओगे तो H2PO4 माइनस ज्यादा होगा। बट ये रेशियो जितना 1 से दूर आएगा, जितना रेशियो 1 से दूर जाएगा, उतना ये ना उसका स्लोप बढ़ेगा। So this is the point where the slope is the minimum. Yes or no? I don't like this color. Naturally, this is the first equivalence point. When you're considering only H2PO4 minus to be maximum and you're using pK1 plus pK2 by 2. This is the only point. Where it's not acting as a buffer. This is the only point where it's not acting as a buffer. Again, see from C to E. From C to E, it's buffer 2 of H2PO4 minus and HPO4 minus, yes or no?
Yes, sir.
Where I can say that at D, this is again the best buffer because this is when H2PO4 minus is equal to HPO4 minus. And again, this is when the buffer capacity is the best. And this is when the slope is the minimum, where the change of pH with the volume of alkali added is the minimum. And throughout this to this point, you move from D to C, naturally H2PO4 will be increasing. You move from D to E, HPO4 minus will be increasing. So both from D to C and D to E, the slope would be increasing. I don't know if I've drawn it perfectly or not, but what I wanted to mean is it's going to be a staircase like of a structure where at B and D, this would be the least slope point. Yes or no?
Yes, sir. As simple as
Allow me to call 2 as the second equivalence point. Allow me to call S as again a buffer where HPO4 minus is naturally equal to PO4 3 minus at 150 ml. At point G, naturally at 150 ml at point G 150 ml, you'll have PO4 3 minus and salt hydrolysis applied. ऐसे ही होता है पॉलीप्रोटिक एसिड में, ऐसा ही होता है। स्टेयरकेस फिनोमेना होता है 1 2 3 स्टेप है, मतलब ट्राइप्रोटिक है। 2 स्टेप है, मतलब डाइप्रोटिक है। तो वैलिक एसिड के लिए, कार्बोनिक एसिड के लिए 2 स्टेप का आएगा, फॉस्फोरिक एसिड के लिए 3 स्टेप का आएगा। आई थिंक आई हैव बीन एबल टू एक्सप्लेन ऑल डिफरेंट पॉइंट्स। You give me, any point between A and B. Any point between A and B. I can say from the region A to B, I can say phosphoric acid is more than H2PO4 minus. From B to C, I can say H2PO4 minus is more than phosphoric acid. This is the point where the two are equal. Yes or no?
Yes,
This is when pH is equal to pK1. When pH is equal to pK1, it's 100%, it's 50% ionization. Don't you love it? This is when the pH is equal to pK2. When the second step is 50% over, half of H2PO4 minus has lost its H plus. So there's something which you'll want to understand inside out so that in any problem of polyprotic titration, you're not caught on the wrong foot. I want to discuss more questions from the given problem sheet. So once you have taken care of this, you can take a screenshot of it. You can draw it perfectly at your end. But we'll need to move on. And solve more stuff. I want to go into problem solving right now. Please tell me if you're understanding me. I'll take up the next question. When it comes to phosphoric acid, I've told you how to arrive at the different values of pH and the concentrations of all the radicals. Maybe one more time very quickly. Can I move on? Are you all happy with this? Please take a screenshot. We have less time. We want to move on. बच्चे लोग हाँ ना बोलो. बच्चे लोग हाँ ना बोलो.
Yes, sir.
Now, when it comes to solving questions, routine questions, well, I have a question at hand where I have to find the pH of 0.1 molar NH2PO4 and 0.2 molar NH2SPO4. So question 2 in the given problem set, you have to find the pH of 0.1 molar NH2PO4, I believe, and 0.2 molar Na2SPO4. Naturally, the values of pK1, pK2, and pK3 are staying put. And yet again, I tell you from the standpoint of solving equation, you got to be very, very clear about this. This 0.1 molar or 0.2 molar is not going to make a difference. NH2PO4 amphiprotic, it's going to be pK1 plus pK2 by 2. Na2SPO4 under amphiprotic, it's going to be pK2 plus pK3 by 2. Yes or no? So when it comes to finding the solution only, this is going to be the simplest question of the paper, maybe. There was a lot of, interesting stuff to be taken home. Let's move on. Question 3. Are you happy with this? Are you happy with this? Question 4 is a real nice problem. Question 4 is a real nice problem. This is very routine. Amphiprotic species. Please respond with a yes or no. We'll want to move on. बच्चे लोग हाँ ना बोलो. We'll want to move at a faster pace. Question 3 is also simple, but question 4 is going to be a really nice problem. Question 4 is going to be a really nice problem. So far, so good, I believe.
Question 3 is 10.1, right? Answer was
3 is simple. 3 is simple. Bicarbonate and carbonate. Question 3. Question 3 is you have a mixture of 0.4 molar bicarbonate, 0.2 molar carbonate. Find pH of a mixture of. I hope I'm writing it all right. If I make a mistake somewhere, please correct me. Looks good?
So ये बफर बन गया ना?
You सभी है ना?
हाँ सर.
You're doing good. For the first class, you're doing good. Not in terms of the answers which you're giving, which is absolutely right, but in terms of the participation you've had in the class. This is really nice on your part, to have been really responding in the class today. Keep it up. Obviously, people in the class know that it's a buffer. I would again want, Utsavi to be, really good at responding. It's a buffer. Most of the people in the class right now know this. Had it been only bicarbonate, it would have been pK1 plus pK2 by 2. Had it been only carbonate, it would have been salt hydrolysis. But from the standpoint of mixture, it's going to be a buffer, which is going to be pH is equal to pK1 or pK2.
pK2 because
Paka.
it's yes sir because HCO3 और CO3 2 माइनस में है ना तो मतलब एक और एस डिसोसिएट करेगा तो pK2 होगा वो.
ठीक है बहुत बढ़िया करिए 11 minus log 4 plus log 2 यही है ना.
यस सर.
10.1 आ रहा है क्या?
सर आप शायद से उल्टा लिखे 0.2 by 0.4 होगा.
ठीक है यार मैं कभी कभी गलती कर भी देता हूँ और मेरे को बहुत अच्छा लगता है अगर कोई स्टूडेंट मेरे को करेक्ट करता है.
तो माइनस लॉग 2 हो जाएगा. हाँ
सॉरी अबाउट दिस. Rest is all right?
यस सर.
Yes, we can move on. Question 4. Question 4, my friends. Question 4. 4 is a real good problem. I would want somebody, to give me a solid solution to problem 4. Question 4 is about 20 ml of 0.1 molar phosphoric acid, 20 ml of 0.1 molar phosphoric acid plus 20 ml of 0.1 molar sodium phosphate. Find pH of this mixture given the values of pK1, pK2, pK3 in terms of expression only. Yes, please. How do we go about it? Yes, please. How do we go about it?
फर्स्ट वाला तो वीक एसिड वाला पॉलीप्रोटिक फॉर्मूला से बन जाएगा. सेकंड वाला क्या वो लगाएंगे सॉल्ट हाइड्रोलिसिस.
अरे दोनों मिक्सचर, इट्स द मिक्सचर, दोनों साथ में, इन दोनों को मिक्स कर दिया. ये
So
दो
one
अलग-अलग
is
solution था.
equal
इसको इन दोनों को मिक्स किया, इन दोनों को मिक्स किया, इन दोनों को मिक्स किया. ये दो अलग-अलग सॉल्यूशन था. ये दोनों, ये ऐसा नहीं कि इसी फॉर्म में एग्जिस्ट करता है. ऐसा नहीं है दे कोएग्जिस्टिंग टुगेदर. It's like you have mixed them together. Take it like you're adding HCl to NaOH. It's
सर
not like it don't exist as HCl or NaOH.
सर इन दोनों को मिक्स करेंगे तो H2PO4 माइनस और HPO4 2 माइनस का मिक्सचर बन जाएगा ना.
बहुत अच्छा बोल रहा है भाई, मेहुल भाई बहुत अच्छा बोल रहा है.
मतलब
Considering K1 is much more than K2, which is much more than K3, I believe that the more phosphoric acid is tempting to act as H plus donor, the more is phosphate acting to act as tempted to act as H plus acceptor. So from the values of K1, K2, K3, which we are told in general about polyprotic titration, I read this to be a very strong acid, H plus donor, and this to be a very strong base, which is H plus gainer. It will lose H plus. It will gain H plus. So the moment you put these two in contact, this would lose H plus and this would gain H plus. Hey, are you there with me? K1 much more than K2, much more than K3 would mean in their mutual presence. In their mutual presence, this will act as an acid, and PO4 3- will act as a base. This is knowledge you need to take home. You getting me? ये 2 मिलीमोल है, ये H प्लस छोड़ के 2 मिलीमोल ये बन जाएगा, और ये भी 2 मिलीमोल है, ये H प्लस लेकर के 2 मिलीमोल बन जाएगा. तो इवेंचुअली इट विल बी अ मिक्सचर
अब तो
ऑफ
बफर
2
बन गया.
मिलीमोल 2 मिलीमोल.
बफर ही बन गया. तो
असल में उसका pK2 आएगा.
हाँ PK2
I mean,
2/2 log 1 हो जाएगा.
one way of writing this could be,
I don't understand.
Not a problem.
वापस एक्सप्लेन कर सकते हो please?
Not a problem. You'll take your time. You can take your time, not a problem. Please take your time. When I write it in this form, when I tell you that this is a kind of reaction which can happen between these two, it's pretty natural. When you are imposed a formula, an equation, this is what happens. Phosphoric acid, phosphate, it will lose H plus to become H2PO4 minus. This will gain H plus to become HPO4 minus. Trust me, I'm not telling you a story. K1 much more than K2, much more than K3. They differ so much that in the mutual presence of these two, this needs to move back and this needs to move forward. What's the problem?
Understood.
You just don't need to understand this. You need to take this information home. I mean, at any point of time, I would be the one telling you that whether you add phosphoric acid to water or you add sodium phosphate to water. I mean, I do tell you, there was a question way back in IIT. You dissolve carbon dioxide in water. This is such a common question. I do talk about it every now and then. When you dissolve carbon dioxide in water, you dissolve carbon dioxide in water. You dissolve carbon dioxide in water, or you add carbonic acid to water. The species which you get, species in water, the species in solution. I know they were all right options. H2CO3, HCO3 minus, CO3 2 minus, and I would add more to it, H plus OH minus, because it's water, you know, all are going to be right. यहाँ पर option D all था, यहाँ पे तीनों ही था. So this is the rule of equilibrium. You know, when you write H2CO3 becoming HCO3 minus and CO3 2 minus, they're all going to coexist. They're all going to coexist, but their relative amount will depend upon a lot of facts. In this case, the relative amount will depend upon how much phosphoric acid, how much phosphate. So let's understand that, you know, the three coexisting together with this 2 millimole and this 2 millimole, you know, this would agree to lose H plus and this would agree to gain H plus to arrive at 2 millimoles of this and 2 millimoles of this. And naturally, pH would be like pKa2 plus log of 2 by 2. Yes or no? Take it from first principles. Don't make life difficult for yourself. But chalo, we want to move on. Basically, I'm waiting for you.
Yes,
That's
sir,
it,
yes, sir. समझ में आ गया.
Is are you there?
Yes, sir.
जो भी है क्वेश्चन 5 K1 K2 दिया हुआ है बाइकार्बोनेट निकालना है कार्बोनेट निकालना है पीएच निकालना है आई थिंक बाय नाउ वी हैव some expertise at this H2CO3 H plus and HCO3 minus and HCO3 minus H plus and CO3 2 minus okay say this is K1 I'll say this is K2 the values are given to be 4 into 10 to the power minus 7 7 into 10 to the power minus 11 so this is 4 into 10 to the power minus 7 and this is 7 and 10 to the power minus 11. Please
Option D.
respond. Yes, please.
सर H प्लस का कंसंट्रेशन HCO3 माइनस का कंसंट्रेशन के साथ सेम होगा तो K1 में रूट K1 इंटू सी आ जाएगा
रूट
HCO3
K1
माइनस
C.
का.
Answer bool. Answer bool.
Option D, 10 to the power
-4
minus
आ रहा है सर.
क्या बोल रहा है
10 to the power minus 4, sir. Option D.
ये ऋतिक से इतना चुप चुप क्यों है मेरे को समझ में नहीं आ रहा यार ऑल गुड ऋतिक साहब
हाँ सर, अभी सारा सॉल्व करके नहीं रखा.
बट आई थिंक यूर अंडरस्टैंडिंग मी
हाँ सर.
कम से कम गलती तो मेरा बताती रहे कि सर 2 माइनस नहीं होगा 1 माइनस होगा खाली
ठीक है सर.
क्या HCO3 minus is equal to
10 to
H
the
plus is
power.
equal to CH is equal to root over of K1 into C लिखूं क्या अरे बोलो
Yes, sir.
which is 4 into 10 to the power minus 7 into 0.025 we get 10 to the power minus 4 आ गया
Yes, sir. हाँ सर 10 to the power minus 4 ही है.
अच्छा pH वैल्यू का माइनस होगा 10 to the power minus 4 ये 4 ही आएगा और कार्बोनेट का वैल्यू K2 के बराबर आएगा ये पक्का है तो
हाँ सर.
कार्बोनेट का वैल्यू K2 के बराबर में इसका आदत पड़ गया तो कार्बोनेट का वैल्यू K2 के बराबर में HCO2 माइनस का वैल्यू K2 के बराबर में इसका आदत पड़ गया तो बच्चे लोग बोलो यार
Yes, sir.
यहाँ पर भी क्या है देखना 10,000 का डिफरेंस है तो सारा H प्लस ई से आ रहा है सारा H प्लस ई से आ रहा है मतलब ये ऑलमोस्ट डिफरेंशिएट कर ही नहीं रहा है ये दोनों बराबर है अभी ये दोनों बराबर है ये दोनों बराबर है ये दोनों बराबर है तो K2 के बराबर ही होगा ना कार्बोनेट बोलिए बोलिए आगे बढ़ते हैं आगे बढ़ते हैं खत्म करते हैं यार 10:15 बजने की 10:15 हो गया क्वेश्चन 7 पर 6 हो गया आप 7 देखे
Yes, sir.
हाँ सर
7 का आंसर क्या है
सर D10 है क्या?
मालूम नहीं 7 का आंसर क्या है कॉमन आंसर क्या है फॉर H3A K1 कितना बोलता है, K2 कितना बोलता है? मैं खुद ही क्वेश्चन पूछ रहा हूँ, खुद ही आंसर, कोई जवाब ही नहीं दे रहा। सब लिखा हुआ है प्रॉब्लम में।
हाँ सब दिया हुआ है।
फाइंड px ऑफ 0.1 मोलर, क्या बोलते हो, H3A, यही है ना, वेयर
हाँ
x इज इक्वल टू क्या है,
Px is equal to
A3 माइनस अपॉन
A3 minus by H8 minus 2 minus Ha2 minus Ha2
ये
minus।
क्या,
हाँ हाँ हाँ
क्या आंसर क्या है, मेरे को क्या आंसर है तेरा, बोल जल्दी आंसर बोल।
सर हम निकाला नहीं है, हम निकालने दीजिए, एक मिनट दीजिए।
क्या यार, दिस इज सो अनकैरेक्टरिस्टिक ऑफ यू।
सर H प्लस को K1 से ही तो हम लोग फर्स्ट उससे ही तो ऑब्टेन करेंगे ना, H3 H2A माइनस से। तो सर वो
हाँ हाँ
रूट K1 इंटू C से H प्लस 10⁻³ आ रहा है। और लास्ट में
बढ़िया बढ़िया बढ़िया,
K3 का जो इक्वेशन लिखेंगे उससे ये आ जाएगा Px।
ठीक बोल रहा है। K3 से हम लोग लिखेंगे
सर 10 ही आ रहा है,
x प्लस,
ठीक बोल रहे 10 आएगा।
x प्लस लिखेंगे रूट K1 इंटू C, तो A3 माइनस अपॉन Ha2, A3 माइनस अपॉन, ठीक बोल रहा है बाबू, K3 अपॉन H प्लस, यही होगा ना, और Ka3 अपॉन H प्लस इज रूट ओवर ऑफ K1 इंटू C। तो क्या आता है, 10⁻13 अपॉन रूट ओवर ऑफ
और वो
10⁻5,
-3 आ जाएगा।
कितना 10⁻10 आ गया ना, बस खत्म।
बिल्कुल 10 आंसर हो गया।
Minus log of this is minus log of this is px is minus log of this. So px is
10.
ठीक है। ये सब रियल एग्जाम का प्रॉब्लम है, ये सब जेईई मेंस का क्वेश्चन है। क्वेश्चन 8, क्वेश्चन 8, 50 ml of 0.05 ml of carbonate plus 40 ml of 0.1 HCl। अच्छा प्रॉब्लम है, करो बच्चों।
ऑप्शन डी है सर 6.173।
ये तो सभी एकदम खतरनाक कमाल की है। इसके पहले हमसे पूछ रही थी, समझ में नहीं आ रहा है फॉस्फोरिक एसिड और फॉस्फेट क्या कर रहा है, अब ये वही काम खुद कर रही है।
सर
क्या कर रही है,
सर उसमें Na2CO3 प्लस HCl किए तो NaHCO3 बना, Na2CO3 2.5 है, HCl 4 है, तो HCl आपका 1.5 बचा, NaHCO3 2.5 बचा। फिर NaHCO3 प्लस HCl में वही सेम चीज की है, तो NaHCO3 1 बचेगा और H2CO3 1.5 बचेगा। फिर pH निकालेंगे तो हम लोग इसमें 6.35 यूज करेंगे।
तेरा सब कुछ राइट है, तू परफेक्टली कर रही है, आंसर भी ठीक कर रही है, अब ये तू लाइन पे आ गई है पूरा, आई एम हैप्पी विथ यू, ठीक है, गॉड ब्लेस यू, चल बहुत बढ़िया। चलो घूम फिर के कहानी चाहिए ना कि कार्बोनेट वेस्ट प्लस जाएगा तो इक्विलिब्रियम पीछे आएगा। बात देख वही है, K1 मच मच मोर देन K2 में, मैं वही तो बोल रहा था कि अगर K1 बहुत ज्यादा है, K2 इसका मतलब है कि अगर अच्छा, फिर इसका मतलब बहुत स्ट्रॉन्ग बेस है। घूम फिर की बात वही है। एक बात बताऊं, यहाँ पर HCl दे रहा है तो तेरे को कॉन्फिडेंस है इस बात का कि HCl का H प्लस इसको पीछे ला रहा है, पर एक बात बताऊं, कार्बोनेट में अगर कार्बोनिक एसिड डालते ना, वो भी इसको पीछे लेकर के आता। अरे हाँ बोल।
हाँ सर, मतलब पीछे तो जैसे हम लोग डिस्कस किए थे क्वेश्चन 4 में।
होता क्या है ना, जब अपने को प्रॉब्लम में दिया था ना कि 50 ml ऑफ 50 ml ऑफ कितना है, कितना मोलर है,
0.05।
होता क्या ना, जब HCl दिखता है तो हम लोग को कॉन्फिडेंस दिखता है, HCl स्ट्रॉन्ग एसिड है। पर मैं पहले ही बोला हूँ, न्यूट्रलाइजेशन ना कभी भी स्ट्रॉन्ग एसिड और स्ट्रॉन्ग बेस का मोहताज नहीं होता है। H plus OH minus forming water is always going to be a terrific reaction. The same thing would have happened had you added H2CO3. Maybe, in that case, about some H2CO3 is left, would have been a different scenario. But it's all about adding 4 millimole of H plus. Now, 4 millimole of H plus to begin with 5 millimole of carbonate, with 4 millimole of H plus. I think I'm doing it all right. नहीं 2.5 है ये, सॉरी 2.5 है, ये 2.5 होता है ना, ठीक कर रहा हूँ ना, 0.5 था। तो 2.5 मिलीमोल H प्लस क्या करेगा, इसको पहले कन्वर्ट कर देगा एंड यू विल गेट, ये खत्म हो जाएगा। मतलब मैं पहले ऐसे एक इक्वेशन लिखता हूँ, बच्चे लोग हाँ ना बोलते रहो।
हाँ
Yes.
सर।
कि ये मान लो शुरू में 2.5 मिलीमोल है, ये 4 मिलीमोल है, तो ये क्या हो जाएगा, खत्म हो जाएगा, ये 1.5 मिलीमोल बचेगा और ये 2.5 मिलीमोल बनेगा। फिर हाँ ना नहीं बोलते।
यस सर।
अब वापस HCO3 माइनस में H प्लस डाल करके इसको H2CO3 बनाओ, और अगर ये 2.5 मिलीमोल था और ये 1.5 मिलीमोल था तो ये 1 मिलीमोल बचेगा,
और वो 1.5 बन जाएगा,
ये 1.5 मिलीमोल बन,
ये बफर हो गया।
ये बफर हो। तो pH इज इक्वल टू
pK1
pK1 log of 1/1.5, which will be like pK1 plus log of 2/3, which could be written as pK1 plus
log of 2 minus log of 3.
log 2 minus log 3। यहाँ से एकदम परफेक्टली आंसर निकाली है लड़की, बहुत अच्छा काम किए, 6.173 लाइए।
यस सर।
गुड जॉब सभी।
थैंक यू सर।
Question 9, the types of buffer form will be 3.
3
ये एकदम बिल्कुल रूटीन क्वेश्चन है। I don't want to spend my time and energy over this. If required, I'll discuss it in the live class when I see you. Stay happy, stay healthy. It was nice, spending 1.5 hours. Also, see you tomorrow then. Stay happy, stay healthy. मिलते हैं बच्चों। Bye bye. God bless you.
सर
बोलो तो।
सर आपको डाउट्स भेजा था सर व्हाट्सएप पे।
तेरा जितना डाउट्स है सबको मैं प्रॉब्लम शीट में मिला करके कल क्लास में ले आया। क्या बोलते
पर
हैं?
मेरा भी डाउट्स था।
ओके सर।
सब भेज दे। आने का भेज, अभी आने का भेज। हाँ
सर आयनिक तो
सारा एनिक ही है सर।
क्या?
सर आयनिक का छोड़ के बाकी सब डाउट्स है उसमें।
बस 1-2 दिन के अंदर में, 2-3 दिन के अंदर में मैं सब करा दूंगा। अभी आने का जो वो कल से
ओके
एटॉमिक
सर।
स्ट्रक्चर परसों, ठीक है?
हाँ
रेडॉक्स
एटॉमिक स्ट्रक्चर का भी है उसमें 1-2 ठो।
सब भेज। हाँ
हाँ सर अभी आयनिक ही करेगा आज।
मिलते बच्चे लोग। बाय, गुड नाइट, सी यू देन।
बाय सर।
बाय
बाय सर।
बाय
बाय बच्चे।